Howdy again, Christmas vacation time, but I'm going to talk about soft jaws. Now, I used to have not this particular picture, but I used to have this in my toolbox at work when we had to make soft jaws because we would either have to measure a set of Kurt soft jaws or other brand soft jaws and make sure we could make some jaws when we needed them. So we used to always use 1x2 aluminum bar stock. We would cut these off to length, and we wouldn't machine the ends. We wouldn't machine anything except the holes. And this works pretty good. You could get super accurate if you machine all surfaces, or you can buy them nowadays. I think 20 bucks a pair, or maybe less. But it's a good idea to learn how to make soft jaws anyway. So what we're trying to do is create the same pattern, and the Kurt jaws are not, they're a specific number. This 940 dimension is distance from where the jaw sits to the bolt hole, and this 3.88 is the spread in between. And this is a counterbore. So we used to try to make the counterbore deep because if we had to cut very deep, we wouldn't want to have the bolt be in the way. So we got a counterbore and a through hole and a 531, which would be a clearance hole. We try not to go too close to the bolt size because it may be resting on the bolt, and the bottom of this won't be sitting on the parallel surface of the vise. So you don't want you just want this to clamp. It's not meant for accurate positioning. So this is a clearance hole, and the same thing goes with the counterbore. The counterbore is bigger than the bolt head and deeper than the bolt head. All right, so you can put in, on our blueprint here, accept raw bar stock for basic jaws, saw cut ends to 6 to 6.1 inches long. And we're actually going to machine this from the middle. So we actually have a program in there all the time, but we could even write a basic G-code program using like G83s and G13s to do the circular pocket milling. But we would do X, Y, and we do X in the middle and Y on this surface here. So when you actually machine this, you want to be machining from the other orientation. I've always been taught to come off the fixed jaw side in order to hold this dimension. Probably not super important, but when you get into good habits, you have less mistakes. So once you have the bolt pattern in there, now we can do anything we want with these. Standard jaw that we use in our shop for Operation 1 is just a cut jaw. We'll make some of these out of steel or aluminum, and here's a model of one that's been cut. So I'm just going to flip this way. So we typically use, let me do inspect here, measure that line. It's 200 thousandths by 200 thousandths. That pretty much good clamping area and makes a good parallel surface. So when I worked in job shops, we'd have these all the time, and sometimes we have to go back in and remachine these. So you gotta either clamp them together or put something in between. I like to use a round piece of material, and I could manual machine these so they're parallel to each other and nice and square. I did see some people way back in the old days that would do dovetail, which is actually a popular way to hold thinner parts. But this is the steel jaw. You probably can get away with maybe down to 100 thousandths to 150, but you'll have to experiment with that. Also, if you make these jaws taller, they're going to start flexing out like this. So, or you might have to make this thicker depending on what you're trying to do. If you're trying to capture a bigger side. The nice thing about the soft jaw is if you accidentally or start to cut into this, you won't ruin your tool, and if you don't go in too deep, the part will still be there, so it won't ruin anything. You could probably still keep on using these and maybe dust the top of this and recut the surface again. So it's really a good tool saver. Plus, with using parallels, you're set with certain numbers. With this method, you can make it exactly what you want. And you can take these in and out, and they should line up perfectly. And that's the soft jaw concept. Now, this is just parallels. So we want to do a particular shape, and the round object's like the easiest one. If you use the Titan 3M as an example, or any round object, we can put a set of these soft jaws in. So we have some of these already machined that look like this blank here coming up. So that's your. So I can model this if I have to do a very specific one, or I can have these in the drawer and ready to go. I throw them in the Kurt Vise. I put a spacer. I have to determine spacing. So probably want to do, if you can think off the top of your head. So I have here, this is a cut pair. I already have a set here already set up. These are blank and they line up with each other. So in this case, I could bring these in and let me do a save as right now. File, save as, and I'll use this as a demo. I'll just say demo. Demo 3M. All right. Don't want to ruin my originals. All right. Close this up. All right. So first thing, either you have your part ready to go or you have this ready to go. So let's actually go get, I'm going to close some of these up. Close that one up, and that's a drawing we have for the shop drawing for the floor. So we'll just use the typical round part. Actually, we have a different one in here. Let me look in. I'll just go the old Titan project, and we'll call it the 5M. 5M is pretty good because you can hold that round object and the star still's on the bottom. So you got to be able to hold on to the part. So if you don't have it deep enough, it might not hold on to the round part. So in this case, we'll take a 5M here, right? All right, here's our 5M, and we're doing it from operation 2, so it's flipped upside. So I'm actually going to go to the design side here. I'm going to have bottom facing me, and let me go back to my recent data here. Recent data, and so I'll just drag these in. So just drag these in. Let's see. Okay, so they're sort of orientated and not quite lined up. So what I'm going to do is just going to move these down here, right? I'm going to hit bottom view, and I'm going to move them this way, right? So first thing you want to do is, how much do I need to capture this by? So let's look at we're going to call this the fixed jaw side. So if I put this in right about there, right? Or maybe there, I have enough round surface to cover that. I'm just going to hit OK for now and take a look at this. Right, oop, I flipped it upside down again. Top, rotate, rotate, bottom facing me. So I'm actually going to save this view. New name view. I'm going to call this one bottom. Right. All right. So I got to get these jaws closer together. Then I can figure out how to get them orientated. So, and this is actually linked right now. It's linked to the original jaws. So I'm going to unlink them. Break link. Because once I change anything in the design, it wants to go back and change the original design. All right. Let me see if I can move this one here. I'm just going to move this physically up here. That looks pretty good. All right. Let me inspect from here to there. And that's 0.9. Oh. So now I got to think of my spacer. What can I use that's, I would like to use something I can just grab and throw it right in there. All right. So if I move this, let's see, that'd be, what if I made them 1 inch apart? Would that be adequate? Or do I need to be sitting on this? I'm going to grab it by the round side, but it's got to sit on this. So I think I want them closer together. Okay, so let me move this one in a little bit. So that's center, and that's not center. I'll go to right about there. Hit OK, and I'll just grab this one. Oops, I'm in the wrong spot. Right there, and move it in. Hit. Now I'm a little bit. I can see the red line where the middle is. So, all right, let's inspect now. Here to there. That's 0.4. So I can put a 0.4 spacer. One I liked was the 1/2 inch one. So if I moved it, that's 0.1. I'm gonna make it 0.05. And this one, I'll make it negative 0.05. Oops. That should be 1/2 inch apart here. 1/2 inch, good. So I can put a 1/2 inch spacer in there. All right. So now I need to, let me put this on the sideways view. I need to move these up. All right. I'm going to go up. Oop. No, I'm floating it. I don't want to do that. All right, I want to move, not free move, I want to translate. All right, how far can I go up? See right there? I think that would be pretty good right there. So I can grab the outside, and if I machine a cylinder, and I'd have enough sticking on top. So let me go up one more click there. Let me put it in between that. Minus 1.65. All right. So that would mean I would do the same with this one. I'm going up. Minus 1.65. Okay. So that would hold it pretty good, just like that. Only I got to cut a cylinder in there. How could I do this? I could do this a couple of different ways. One is actually to draw on top of this and extrude. I could do a projection. I think I've done projection before. So let me pause for a second and just review my notes. I don't know if I was recording all that time. Anyway, I'm going to do projection, which means I'm going to go to sketch, and I'm going to pick the surface of the jar as my plane, because they're each actually on the same plane. And right here it says create project. Now project. I'm going to select this ring right up here. I need to not select that one, I gotta select this one. And selection filter specific entities, hit OK. Finish sketch and double click. Now let me shut the body off. So I got like a purple ring there. So I can use this to machine from, or I can extrude. Let me turn this back on. Body back on. How deep would I need to go? Let me measure from this surface to that surface. That is 550 deep. Okay, Sid, hang on. Okay, back again. So I determined that's 550 deep. So I can either use it to cut, or I might just use it as my boundary for cutting. So I can either remember that, or let me actually model it. So let me take the body out of the picture, and let's see, I'm going to do extrude that one and negative 0.55. Okay, and then let's turn on the other one. Did we lose the other projection? Oh, maybe because it's only.
You have 15 minutes left of computer time.
Oh, I'm getting kicked off. Sketch. Oh, it's still there. Okay. And this one, and about negative 0.55. All right. I think that actually might work pretty good. Let me turn the body back on. So it actually looks correct, right? I think it would work out well without interfering with anything. All right. Let me turn the body off. I'm going to hit File, Save. I'm going to go to Manufacture now, right? Oh, this is my part right there. With body off. Oh, actually the material wouldn't. Let me shut these off. Alright, yeah, that actually would work pretty good. Okay, so I got my X, Y, Z. Oh, it's rotated this way, like that. Yes. Alright. So I'm going to do a new setup. New setup. And model orientation and stock box point, and we got to go off the jaws. So I'm going to say manufacturing model is, no, not the manufacturing model. I want to pick these, this and this. Goody. Okay, box point, stock model orientation. I want to do Z and X. I want Z to go, Z's correct, and flip X, and I want, where do I want this to be? Material size, I'm going to be from solid, I think. Well, fixed size box. Oh, that would be pretty good. All right. And I want it to be on top of the, yeah, because we're only machining this. All right, hit OK. All right. And I'm going to just relabel this Soft Jaw. Okay. I'm going to take care of some stuff here. I'm going to call this 1003 Titan 3M Soft, Soft Jaw. And I'm actually going to call this work offset 5, which would be G59. So just in case we don't ruin any offsets we have set up in there.